Now let's go back to the interaction system. First of all, we need to define the input key for our interaction. For this, go inside the project settings, then search for the category named input, and here let's add action mapping, rename it to interaction, and for the key I'll go with E key. Just like this. The next thing we need to do is to define a custom collision channel for an object, so when we will interact with our interactable, we won't be iterating through the whole types of entities we have in our project, but for the proper one. For this, in project settings, search for collision category, and in object channel, let's add the one we need. Press new object channel. I'll go with the name of Interactable. And as a default response, I'll go with Ignore. Just like this. Next thing is to create the interface for our interaction system with the basic methods. For instance, we have two events, start interacting and stop interacting. As the example of the usage of these events, we can go with the interaction widget. If we start interacting, the event will trigger filling the bar of our interaction widget, and after this we need to stop interacting with our widget, so we'll use stop interacting. Now let's go to our blueprint folder and next to the interfaces folder. Here right click, select blueprints, next blueprint interface. Go with the name of BPI, which goes for blueprint interface interaction or interaction system, as you like. Let's open our interface of interaction system and create two functions. The first one is can interact. The second one is stop interacting. Press compile and save. The next step is to create the interaction system component, which we will add to our player character. All logic for the interaction will be stored in our interaction system component. So let's go to the common folder and create another folder, rename it to interaction system, next go inside it and create a blueprint class which will inherit from scene component. Rename it to BP underscore interaction component. Now let's open interaction component and make some logic. First of all, we need to get the reference for the owner of our component. So search for getOwner. Next, pull a wire from it and search for cast to our player character. Then pull a wire from the result of casting and select promote to variable, rename it to player character, I'm sorry guys, that was my wife texting me, but nevertheless let's continue. Next we need to create a timer. Set time, for instance, 0.2, so our logic will fire every 0.2 seconds. Don't forget to promote the handler to a variable, so when we don't need the logic from our timer, we will clear and invalidate it. Rename it to line trace timer, and now let's create custom event and name it line trace. Just so simple. Now for interacting with our object, we need the way to actually interact. For this, we will use the line trace, but not for the visibility, but for the object. So this way we will prevent from iterating through the whole types of collision channels and use only the proper one. Search for line trace for object. Next, from object types, pull a wire and search for make array. As you remember, we created a custom collision channel. It's called Interactable, so please select it. Now, drag and drop player character reference and search for is valid, the one with the question mark. As our line trace will occur every 0.2 seconds, we need to check whether our player character is actually alive, because there can be a situation where we will line trace, but our player character won't exist and we will get the error. So to prevent it, create this type of logic. Now we need to define the start and end points of our line trace. For this, pull a wire from the reference of our character and search for our camera. Next, pull a wire from the reference of our camera and search for world. Actually get world location. That's one node. The other one is get forward vector. So we will actually know the direction that we are tracing at. Now we need to define the length of our vector. So from the get forward vector, pull a wire and search vector multiplies float. Go with the value you like. I'll go, for instance, 1000 units. In the real world, it's like 10 meters. Now, let's connect everything, but actually need one more operation to be done. We need to add the initial point of our line trace with the direction to get the vector from one point to the end point. And so we can actually visualize the results of our work. Set draw debug type to for duration. In duration field, go with small value. For instance, 1. It means the result of our line trace will be displayed for 1 second, then it will disappear. And now, after we compile, we actually need to go to our pledge character and add our interaction component to it. Press compile. Now we can launch the game and see how it actually works at this moment. Well, as you can see, we are firing the lines, so everything works fine and we can continue. Now let's talk a bit. I will create one parent or the base class of interactable object, and we will create various children inherited from this class. Each child will have its own interaction time, also its own shape. For instance, this one, the blue one, can be the elevator, the yellow one can be doors, the red one can be just a pack of cigarettes that we can pick up. And each child will have its own logic. So, I hope you understand the idea. Now, let's implement this behavior. Before we start, don't forget to select None in Draw Debug type, so there won't be any line traces visible during your gameplay in editor. Let's go back to the content browser, and here in the interaction system folder, let's create another folder, or maybe here we will create our base class for the interactable item, and then we will create folder to store all children of this interactable base class. So press right mouse button, select blueprint class, then select actor and rename it to BP_interactable. Now let's open our interactable base class. Here we will define the logic for our widget interaction. This class doesn't need any primitive component. Only children will need it. For instance, some children need to have static mesh component. Maybe other children need to have skeletal mesh component. So it's up to you to decide what type of interactable object you will create. The purpose for this class is to tell how long should I press or hold the key, so the logic implemented in the children will fire. I'm sorry guys, that's my neighbor. But as you remember, we have created the custom channel collision for our interactable object. As you can see, the base response is ignore. So right now I think it will be much more easier for those who don't have much experience in Unreal Engine. Change the default response from ignore to block. So the behavior will be like it's a physical object. Next, go back to Interactable, and as you can see, we don't have any primitive components, but we need to change the default collision class for all our children from the default one we have in our engine to be an interactable. For this, on event begin play, we need to create the following kind of logic. Search for set collision type. If you don't see anything, just uncheck context sensitive checkbox and you'll see the nodes we are looking for. Connected. Also, press right mouse button and search for get component by class. The idea behind the interactable object is so we are actually interacting with only one piece of it. Basically, it will be the trigger. So your root component or main primitive component should be only as one instance, not 2 or 3. So let's continue. In component class field of get component by class node, switch actor component to primitive component. Primitive component can be actually any type of geometry, as a static mesh and as a skeletal mesh. Connect everything and in set collision object type node, change channel from world static to interactable. So all children that are inherited from our base interactable class, when they are spawned in our level, will have interactable type of channel. So when you create a child and add static or skeletal mesh component, you don't need to think about changing its collision type. It's very useful. Now, press on class settings in our interactable base class and add the interface for our interaction system. BPI interaction system. Press compile. Now let's add our events. Right click and search for can interact event, and the second one is stop interacting. As for quick demo that we are actually on the right way, let's print from both of our events the debug prints. When we can start interact, we will print hello, and when we are done with interacting, we will print bye. Now let's go to our interaction component and continue with developing our interaction logic. So, as you can see, we are trying to line trains from our camera to some point. We are tracing by specific object, it's interactable object, and we need a condition. Add branch node, then let's see whether we have a collision, then pull a wire from out hit output of line trace for object node and select break hit result. You can expand this node and see the various of attributes. Next, if we actually hit something, we are looking for the hit actor, then pull a wire from hit actor and promote to variable, so it will be our local reference. Call it last interactable. Last interactable means the last instance of interactable object that we are actually have interacted. So, next, pull a wire from our last interactable and search for can interact message. Because we are using the interface, we don't need cast to it. So if the hit actor was actually the interactable kind of object, the message will be delivered and we will see the hello print. And if there was no hit result with the interactable kind of object, we need to stop interacting with our last known interactable. So pull a wire from our last interactable and search for stop interacting message. Now press compile. Next, what we need to do, we can go with the base class, but let's create a child of our interactable. So select it in the content browser, press right mouse button and select create child blueprint class. I'll go with the name of BP ball, because it will be just the ball. So when we will interact with it, it starts moving. Go inside our ball and add static component. As I said earlier, it can be static or skeletal one. For my purposes, static mesh component will be the proper choice, and in static mesh category we need to select sphere, because I don't have any other content here. It's just the raw project, but we can actually use the content from the engine. For this, press on the eye icon in our content browser and select Show Engine Content. Just by these actions, now we can actually see the content from our engine. Here, search for sphere and let it be sphere from the basic shapes. Press compile. Now all we need to do is to drag and drop our ball to the scene and launch a game to see how our interaction in its basic form will work. I'm sorry guys, please be patient. Now we have launched our game. Let's go forward and turn to our ball. As you can see, we have hello print when we are actually starting in our ball, and print by when we have stopped interacting with it. One more time. Interacting, stop interacting, interacting, stop interacting. But we don't need to trigger this event so many times. We only need to interact it once and stop interact once too. So let's create this kind of logic. So to make our can interact and stop interacting messages fire only once, we actually need do once node. We only need to fire once every our event, but not once for the whole game cycle, but for each interaction cycle. So basically, when we don't provide any reset events, we can have this kind of situation. Hello. And nothing happens. So for this, we need to connect everything this way. So we have the cycle. When we interact one time, we reset stop interacting. When we stop interacting, we reset can interact. And now everything will work as it intended to be. Hello, bye. Hello, bye. Hello, bye. Once per interaction. You can go with this setup, but actually you can go with the custom event to keep your blueprint more attractive and without any spaghetti wires. I'll show you how. Like this. And another event. Like this. Now Let's rename them to reset, for example, stop interacting, and this one to reset can interact. It's just the example to show you, so you can try it or not, it's your choice. And to fire them properly, here we need to search for reset stop interacting, and here reset can interact. Now press compile and check it one more time. Hello, bye. Hello, bye. Hello, bye. Now everything works perfectly, and you can rearrange it so it will look simpler. So let's continue. Now let's create the interaction widget. For this, go into GUI folder, next to the HUD folder. Here, right click, select user interface, then widget blueprint. Rename it to HUD_interaction. Next, under Palette panel, search for image. Drag and drop it to the canvas panel. As for the anchor, you can go with whenever you like. It really doesn't matter because this kind of widget will be used as a screen widget in our world. I'd like to rename it, so for this element I'll go with the name of icon. Or actually it's not an icon, this will go for the progress bar, radial progress bar. And that's my kit. Now guys, as you can see, I have made some little changes to the size, anchor and alignment of my widget, but we actually don't have radial progress bar material applied to our widget. So we need to fix it. And I strongly recommend to avoid using the bind method, especially for the elements that have no states. For instance, you have a static image, and if you use the binding to display it on your screen, here it will update every frame. For the sake of performance, the best practice is to use setting your materials to the images or other elements of the widget by using the functions in the graph with construct and pre-construct events. So we actually need to use the pre-construct event instead of construct. The difference between these two events is that the pre-construct on compilation will apply our logic, for instance displaying the element of the widget just in the designer, and when we use the construct event, it will only fire changes we made, not in the designer, but when the game actually launches. So, to preview the results of your work, we need to use the preconstruct. So, right click, search for create dynamic material instance, next, for the parent field, search for our material instance, radial progress bar. Provide the return value to a variable, so we have the local reference for our material. Go with the name of MID, which goes for material instance dynamic, the score, radial progress bar. Next, pull a wire from the reference of our material and search for make brush from material. As you can see, we have the width and height of our material, and if we have checked size to content, the dimensions we set in the designer will be dismissed, and dimensions we actually set from our graph will override the one we have in our designer. Wait for a moment and I'll show you how it actually works. Next, drag and drop the reference for our radial progress bar, pull a wire and search for set brush. Select the first one, make sure that the target is the image. Next, connect everything. Then press compile and let's see. As you can see, we have our material applied to our image, and as I said earlier, if we have checked size to content attribute, changing dimensions in designer actually have no effect. If we switch it off, you can see that now the dimensions are actually set from our designer. Well, I prefer to use the dimensions from the graph. Here I'll go with 96 by 96. Press compile, and as you can see, the result is applied. Let's move on. Next, I'd like to add the text element and align it to the center of the radial progress bar. Here we will display the button we need to press to actually interact with the object, and when we hold it, the letter will change to a timer to show how much time we need to actually hold our key. So set is variable for the text element of our widget. I'll rename it to key, and for the example of text I'll go with the key of E, just to see how it actually will be displayed. As you can see, it's not in the proper way, so we need to change the alignment. For this, we actually need to check size to content, and everything is fixed. Just change the size of the font from 24 to 28. Well, I like the result. Maybe not bold typeface, but regular one. Yeah. Now let's go back to the graph and create a function that our interaction widget actually will change. So on your left, search for functions and create the new one. Rename it to update progress. Well, actually, let's change it. Not update progress, but update progress bar. Yes. Now we need to add two inputs. The first one will be for the percent of filling our progress bar. So go with the name of percent. Change the type to float, and the second attribute is interaction time. Type float 2. Interaction time, it's how much time we actually are holding our key. Next, this function will be updated every frame to track whether we are actually holding our key or not, and providing the interaction time for our widget to fill the bar. So, to prevent some situations whether our character is killed or something else, we need to search for is valid and provide as the input object our brush material. Because when we hold our key, we are actually will be setting the value to our material instance radial progress bar. We will actually be changing the percentage. So when we have the null reference of the material, and material is dedicated to the life of the widget, which is dedicated to the life of our character. So if it's not valid, we will have the errors while trying to change the material that doesn't exist. So make sure to set the validation logic. So whether we have the valid reference, pull a wire from it and search for set scalar parameter value. Then right click and search for get percent. It's the more clear way to work with the functions instead of just pulling a wire from the whole graph. Then we need a condition to actually change or to check if we are holding key, then our letter should change from its value to the timer to display how much time we need to hold our key. If we don't hold the key, we are just staring at our interactable object, there should be displayed the letter we need to press. So add branch node. Now search for interaction time and if it's less or equal 0, we should actually display the letter. If interaction time is not equal or less than 0, then we actually need to display our interaction time. Now drag and drop the reference of our text. In our case it's the key, the name of key. Pull a wire from it and search for set text. Here we need to set what actual key we need to hold. In our case, just like in the preview, it's the key of E. If it's false, we actually need to display our time. Now, update progress bar function is done, and we can move on to actually make our widget interactable. One moment, I forgot to provide the name of the parameter we actually are changing in our material. Right now it's none, so make sure to set the proper name so everything will work in proper way. Go back to the material instance of the radial progress bar. See the name of the attribute we are changing. It's called percent. Then go back to our interaction widget and change parameter name to percent. So only now we are actually Good to move on. Now let's add our widget to the base class of interactable object and make simple logic just to see how our widget is working together with our interactable object. For this, add new component. It's the widget type. Next, on your right, under the user interface category, for the widget class, select HUD interaction, and for the alignment, change world to screen. Then, by default, our widget actually should be not visible. So, change its visibility. So, by default, it's hidden. Next, when we can interact with the object, we actually should make our widget be visible. For this, drag and drop widget to the graph, then pull a wire and search for set visibility. Check new visibility. And when we actually stop interacting, we should switch off our widget. So uncheck new visibility. Now press compile. Then all the logic that we make in our parent class is inherited by its child. So, as you can see, our ball blueprint now has the widget. And if you go to the viewport, well, actually, right now you don't see anything, because by default, the visibility of our widget is switched off. Nevertheless, we can see how it will work in our game. So let's launch it. So let's launch the game and see. As you can see, everything works just as it's intended to work. You should correct the length of your line trace casting, so you actually won't interact with the object within 10 meters, as we have right now, but perfectly. Let's continue. Now, let's go to our player character and add the interaction input. Search for interaction under Actions event. Next, we need to add the gate node. This gate node will help us to control how much time we are actually holding our key. The idea is pretty simple. When we press our key and start to hold it, the gate is opened and the flow is executed. When we release the key, the gate is closed, so the execution stops. Then we actually need to measure our holding time. Press right mouse button and search for Get Input Key Time Down. Actually, we don't have this option because we are in the character class. For this, right click and search for get player controller, and right now pull a wire from it and search for get input key time down. Provide our key, and let me show you how it will work without the gate. For instance, search for print node connected to press, and the return value of get input key time down node connect to the print. Press compile, and now let's launch our game. Now I'll press the E key and you'll see the print of how much time I was holding it. As you can see, I'm actually still holding my key, but nothing happens. It only fires for one frame. So to fix this, we need our gate. When we press the key, we actually opened the gate. When we release our key, we need to close it. After this, we will add the print node to see how much time we are actually holding our key, but we actually need to provide the enter. Enter means how, or actually the frequency of this gate is updated. So basically, we need our gate to be checking whether we are actually trying to open it every frame. For this, we can go with tick event. Now, press compile, let's launch and see how much time I am holding my key. As you can see, it's accumulating because the gate is open, and when I stop pressing, it will close, and actually no input right now. One more time. 1 second, 2 seconds, 3 seconds, 4 seconds. The gate is closed. Everything works fine. And just to make this look more prettier, let's actually create a custom event. And rename it to update interaction key, or just go with the name you like. I really don't know how to name it properly. Well, I'll go with listen to interaction key. Now, put it on the tick flow. Let's check everything one more time. Yes, everything works perfectly. Let's continue. Now, let's talk a bit. Here you can see the flow of interaction system. we have player and interactable object. We have action A, 1A and 1B. The first one means that we actually see our interactable, it's within our range, and we can start interacting. 1B means that we actually don't looking at our interactable, so we can't interact. Next, when this condition is true, our interactable should send the information to our player character about itself. So basically player should know that interactable is the proper one to interact with, and then player, it's a step number 3, presses the key and begins the execution flow. Actually, these rounds or circles are the demonstration of player holding key. And when this flow actually works, we have a successful cycle, then interactable should execute its own logic, for instance, jump or open a loot box or start the elevator or open the door and so on. So one more time, player sees interactable or doesn't see interactable, then interactable sends the data about itself to our player presses key, then begins the execution flow right to the interactable. If the flow is successful, interactable triggers its own logic. At the moment, we need to create the interface function or event from the interactable so it can send the data about itself to our player. When the player receives this information, we need to create a function in the base class, and all children will inherit this base function, but the logic for each children will be separate, its own logic. So we are actually at the end of our tutorial. Please be patient and you will like the result you see. Now open the interface of our interaction system and let's add new function. Sorry guys, now that's my cat. And let's rename our function to send or provide, as you like, interactable data or info. We also need to add the input. The name is interactable. And switch from Boolean type to BP underscore interactable base. Press compile and save. The next step is to add the interface of our interaction system to play character, so our character and interactable object can work in both directions. For this, go to our play character and in class settings, under the interfaces category, select add and search for BPI underscore interaction system. Now press compile and save. Now in our player character, let's create the event we actually implemented in our interface, which is called send interactable info. Next, pull a wire from the interactable reference and select promote to variable. Rename it to last interactable. So we actually know with what interactable object we have recently interacted. And just to be sure that everything works fine, let's print its name. Press compile. Next, let's go to interactable base class and in the can interact flow, let's add the message to our interface. Search for send interactable info, but we need the message. And for the target, we need to search for player character, as for the interactable reference, search for self. Press compile. Now let's open our child class and compile here. So sometimes the objects that are located in scene, if they inherit the newly created functions, they can actually won't work without the force compilation. And let's launch our game to see what type of message we will get from interaction with our ball. As you can see, BP ball. BP ball. So we are interacting with the object and the object is responding to us. Let's continue. And the last event we need from our interaction system interface is the event for telling the interactable the time we are actually pressing our key. So let's create another function and call it start interaction. So, as you can see, we can interact, then we send interactable info, then we start interacting. As I said earlier, so we also need to add the input for start interacting event and we need to call it interaction time. Change type from boolean to float. Press compile and save. Next, let's go to our player character
And here we need to make some changes. We actually need the sequence. And when we release our key, first we need to close the gate. Then we need to check the condition where the input key was just released. For this, right click and search for was input key just released. Next, add the branch node. And let's check if our key was released. Next, before interacting with our interactable object, we need to check whether it's valid, because this part of logic is triggered every frame. So, search for is valid, the one with the question mark, and provide our last interactable to this node. So we connect everything, and here we need to add the event we actually created. This will be the message start interacting. So if we are good with the valid, we get our last interactable as a reference to the event, and the input key time down as the interaction time. Press compile and save. Now, in the base class of interactable object, let's create some variables. The one, or the first, will be success cycle, or just success. This will tell whether the interaction was successful. And the second one is interaction time. The first one is the boolean, the second one is float. And make sure to check or to click on icon of interaction time variable. So this variable will be the time for actually interacting the object. As I said earlier, we can make our children from inheriting from the base class with their own logic. And this goes for the interaction time for each two. Now, drag and drop the reference of our widget component, then pull a wire and search for get user widget object. Next, we need to pull a wire from the return value of getUserWidget object node, search for cast to HUD interaction, connected to the event begin play flow, so when the game starts we can actually use the function for updating the percentage of our interaction widget. Next, pull a wire from HUD interaction fields and select promote to variable. Rename it to GUI interaction. So this is our local reference to our widget. Now press right mouse button and search for the event start interacting and select the one under the add event category. Next, promote the incoming interaction time to a local variable and rename it to key hold time. Next, you need to create two custom events. The first one is for checking whether the interaction was successful. So rename it to success interaction. And the second one is the main body function, which will fire after the interaction was successfully done. Let's call it main body or main function. This custom event will be the starting point for all the children we have inheriting from the Interactable object class, and the logic for each child will start from this point. Well guys, just to save time, I have arranged the logic for the interaction and I'll show you everything and explain everything. So, when we actually start interacting, we need to cache the time that we are holding our key. Next, we need to check whether the interaction was successful. If it was, because start interacting is triggering every frame, we need to use do once node just to execute the main body of our interactable object. The main body function should be clear in our parent, so when we trigger this event from the child, for instance our VP ball, we can actually execute only the part of logic we want from our child. So make sure to keep clear this event. Next, if our interaction wasn't successful, we need to actually start measuring how much time we are holding our key and update our progress bar. We use save divide node, and we actually divide key hold time by the interaction time to have the percentage. And we need to clamp it from 0 to 1 because our percentage measures from 0 to 1. And if our percentage is less than 1, it means we have no progress, so we need start to measure. The interaction time subtracts the key hold time to have the progress. Make sure to set the interaction time to a proper value, not a 0. For instance, 1 second. It means that after we press and hold our key for 1 second, we'll have the full progress bar and the interaction will be successful. Also, as we did earlier, the cast to our hard interaction widget, we have the local version of our element. We can just pull a wire from it and add the update progress bar function we actually have in our interaction widget. So it will execute. And if the condition is false, it means that we have more than 1 or equal 1, so that our progress bar is full. We need to reset our interaction widget so we can interact one more time and set the success boolean to true. So when it's true, we have this condition and we actually execute the main body. So see one more time. Also, when we stop interacting with our object, we need to reset the successful cycle to false. So when we start interacting other time, our logic will work. Now we will launch our game and see how our interaction actually works. Right now we have some issues we need to fix, so I'll show you how to do this. Also make sure that the interaction time set in your parent actually affects by default the interaction time of your child. So if we go to our BP ball and press class settings, class defaults, we can see that interaction time is also 1 second. To change this, you can change it in the blueprint of your child or in your scene. So let's go with 5 seconds. Now I launch our game and let's test interaction system. So as you can see, we are interacting. Actually, the format of our time is not really pretty. We need to fix the fractional digits number, and as you can see, if we stop interacting, it actually doesn't show the key we should to press, it shows the actual interaction time. We also will fix it. Now, when we have the full interaction cycle, as you can see on your left, is the hello print. But right now I am pressing my key and the interaction doesn't work because we actually need to reset our interaction after the successful cycle. Not just by stepping aside, but after the successful cycle. Also, as you can see, we have the quarter field of our interaction widget. This is because the material instance dynamic should also have the proper starting point, so make sure to set it to 0. Next, let's go to our HUD interaction widget and in update progress bar function, here where we have the path for filling the proper time format, expand to text node and set fractional digits to 1. Press compile and save. Next, let's go back to interactional base and the success interaction flow, let's connect this part of logic. Basically it means when the key hold time equals 0, so we actually stop pushing our button, we need to reset our interaction widget, so the percentage will be 0 and interaction time will be 0. When our interaction time is 0, less or equals 0, it means that we are showing our key. So, press compile and save. Now, let's launch one more time. We are holding, number is prettier, we stop holding, we see our letter. One more time, and one more time. Now, the only thing we need to fix is the interaction, the reset of the interaction. So, to reset the interaction, let's go one more time to our interface of interaction system and let's create another function called reset interaction. And we also need to add an input. It will be interactable. Also change type from Boolean to interactable base. Press compile and save. Next, go to our player character. Here, add reset interaction event. Also, let's add the branch. And we need to check whether our interactable is the same as our last interactable. So we are interacting with the same object. Whether it's true, we need to actually invalidate or set as a null reference our last interactable. Next, search for is valid node. And if we have the null reference, we actually need to close our gate, and this is just a part of the reset interaction logic. Next, we need to move to our interactable base class. Here, in the event start interacting, we need the following. Right click, search for reset interaction message, as for target, go with get player character, as for interactable reference, go with self. Next, need to set success cycle to false. So after successful interaction, we can actually reset the whole cycle and start one more time. After this, we actually need to call the event can interact. Call function. Well, now let's launch the game and see how it will work. Hello. 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 Well, everything works, but we have one issue left. Actually, we have the situation when we have the cached version of our last interactable, so even if we are not interacting directly, we can press our E key and see that the interaction is actually done. So let's fix it, and this will be the end. The easiest and pretty neat way to check whether we can interact with the object to actually avoid such situations that I showed you earlier is to check the visibility of our widget. If we don't have widget visible, we actually can't interact. So get the reference of our widget and search for is visible. Next, we need the branch, connect everything, and connect our validation kind of logic to the success interaction flow. Now press compile and let's see how it works. If we don't have our widget visible, we are pressing our key and nothing happens. When we have our widget visible, we have our logic work. One more time. So that's pretty awesome. And for the end, I'd like to add one more thing about our interactable class. Actually forgot about it. It's the position of our widget. Basically, it's at its 0 coordinates, and for instance, if we look at our child BP ball, you can see that static mesh and widget are on the same level. And if our interactable is a physical body, check select, check simulate physics, Now press compile and let's launch our game. You'll see that the position of widget will actually be on the same position as it was earlier. We need our widget to inherit the position of our interactable. So for this, go to our interactable base class and in the event begin flow, let's add the following logic. We need get component by class with the primitive component. Next, search for component, actually attach component to component, and we need it for our widget as a target and our primitive component as a parent. Now, if you launch our game, we'll see that our widget is actually inheriting the position for our object. So everything works perfectly. Now let me just show you the flow, how to work with our interactable system. Let's delete, actually not delete, but create another interactable object. It also be the ball, but for demonstration it will be pretty much enough. So select interactable base, right click, create child blueprint class. Let's drag and drop it to our scene. Now change interaction time to 3 seconds. Let's edit it. Make sure that event begin play has the core function called parent begin play. If you don't have it, for instance, maybe you just have deleted all the default nodes, then you need the begin play. So to execute the parent logic, you need to select your node, then press right mouse button and add call to parent function. If you don't have it, this logic won't fire. Next, add main body event. This event is the starting point for the logic of your interactable child. Let's add sphere and let's change its velocity by adding an impulse. On the z-axis, just to simulate that our ball is jumping. Also make sure that the sphere has simulate physics enabled. So press compile, change the location of your sphere, and let's see how it will work. Well, everything works fine. So it's all for this tutorial. I'm a little bit exhausted. Leave your comments and feedback. Make sure to subscribe if you like this video, and see you soon.